Okay, so today we are going to start with the chemical bonding. So first, we know if we talk about bond means to join, to stick together, right?
Yes, sir.
So when we talk about a chemical bond, it means we are talking about electrostatic forces of attraction, which hold atoms, ions, molecules together, because the chemical bond is the general term which is specific or which actually refers to all types of bonds between, whether between atoms, whether between ions, or whether between molecules. Is this clear?
Yes, sir.
Okay. So now we are moving towards the specific type of bondings, in which the first one is the ionic bonding. Ionic bonding is okay. First, remember, whether it's a ionic bond or a covalent bond or any other bond, there is always the electrostatic forces of attraction. Okay. So
Yes, sir.
when we say ionic bond, it means it is also an electrostatic forces of attraction, but these electrostatic forces of attraction is between oppositely charged ions. Okay. So if
Yes,
there
sir.
are ions and those ions are attracting each other, then that type of bonding is called ionic bond. Did you understand this?
Yes, sir.
Okay. Now we have an example. For example, if I talk about sodium chloride, sodium is from group 1. So it holds one electron in its valence shell, as we know. So when sodium atom becomes ion, it loses one valence electron, and as a result, it forms sodium ion, which is a +1 charge, right? So here you see it's an atom with
Yes,
the
sir.
electronic configuration of 2, 8, and 1, having 11 protons, so 11 positive charges, and 11 electrons, so 11 negative charges. And if we add them, we got 0. And that's why if you see, this sodium atom has no charge on it. Is this
Yes,
clear?
sir. Yes, sir.
Okay. Okay. Now, that is the electronic structure of sodium ion. So
Okay.
whenever we make the ion, we know you have practiced it from since your O level, that we enclose the atomic structure in the structure of that ion in the square brackets and then put a charge over it.
Yes, sir.
Okay. Now, let's talk about chlorine. Chlorine is in group 7, so it means has a 7 electron in its valence shell, right? So what it will do, it
Yes,
will
sir.
one electron to form a chloride ion, which has a -1 charge. So see, 17 protons, so 17 positive charges, and 17 electrons, so 17 negative charges. That's why chlorine atom has no charge. But when it gain one electron, now instead of 287, its electronic configuration becomes 288. So one electron gets extra. Now 18 electrons, so -18 charges, but protons are still 17, so 17 positive charges. If I add them, I will get this -1, and that's why the ion carries -1 charge. Same here, if you see, after loss of one electron, protons remain same, so +11 charges, and electrons are 10, so -10. So if I add them, I get +1. That's why this ion carry +1 charge. Is this understandable?
Yes, sir.
Okay. Here, if you see, I show the electrons with the dots, and here I show the electrons with the cross. But as you see, I made one electron with the dot, so this electron represents that this electron comes from here, comes from the sodium
Yeah.
atom. Is this clear?
Yes, sir.
That is the electronic structure of a chloride ion. Okay. Now, dot and
Okay.
cross diagram for sodium chloride. So Sodium has a +1 charge, chloride has a -1 charge, so the formula is sodium chloride. So its dot and cross contains only one sodium ion and a one chloride ion. Is this clear?
Yes, sir.
Okay. Now next we have a magnesium oxide. After the class, I will share this PDF with you as well. Okay, magnesium is in group 2. So it means it has a 2 valence electron. So it loses 2 electrons to form a magnesium ion, which has a 2 positive charge. And if we talk about oxygen, oxygen is in group 6. So it have a 6 valence electron. So it gains 2 electron to form an oxide ion. So the oxide ion has a 2 negative charge. Is this understandable?
Yes, sir.
Okay. So as you see, magnesium is 2 positive and oxide is 2 negative. So the magnesium oxide formed will be written as MgO. So it also contains one magnesium ion and one oxygen ion. So whether if you have to draw the electronic structure or the dot and cross diagram of magnesium oxide, we will show one magnesium ion and one oxide ion in it. Is this clear?
Yes, sir.
Okay. Now we have a calcium fluoride. Now there is a little difference over here because the charges are not the values of the positive and negative charge is not same, because calcium is in group 2. So to lose 2 electron to form a calcium ion with a 2 positive charge, right?
Yes, sir.
And fluorine is in group 7. So 2 fluorine atoms. See how many electrons are lost by calcium.
2 electrons are lost.
Okay, and fluorine is in group 7. So how many electrons a fluorine atom can gain?
Only 1.
Only 1. So it means with the calcium, 2 fluorine atoms each gain 1 electron to form and bonds with calcium. And as a result, 2 fluoride ions are formed and each fluoride ion has a -1 charge. Is this understandable?
Yes, sir.
Okay. So see, if the examiner asks you to draw the dot and cross diagram, we will draw it this way. Okay. Sometimes what students do the mistake that this fluoride ion, which I made on opposite sides of the calcium, sometimes what student makes the 2 fluoride ions adjacent to each other like this. They don't make it over here. Instead, they make it another fluoride ion over here. So if you do this way, then it is marked as wrong, because see, both the fluoride ion has negative charge, right?
Yes, sir.
So they are going to repel each other. So they are not going to be adjacent to each other. Is this understandable?
Okay. Yes, sir.
Okay, so this is the dot and cross diagram for calcium fluoride. For example, if examiner sometimes asks you to draw the electronic structure of the ions present in calcium fluoride, if examiner say this way, then you have to show only one calcium ion and a one fluoride ion. Okay, I am repeating it. If examiner asks you to show the electronic structure of the ions present in calcium fluoride. So there are 2 types of ion present in calcium fluoride. One is a calcium ion and one is a fluoride ion, right?
Yes, sir.
So in this, when they ask you to draw the electronic structure, you just draw one calcium ion and one fluoride ion. But when examiner asks you to draw the dot and cross diagram for calcium fluoride, then it would be like this, where one calcium ion is in the middle and 2 fluoride ions are opposite to sides of the calcium ion. Is this clear?
Yes, sir.
Okay. Now we have our next ammonium chloride. Okay. Tell me, ammonium chloride is a ionic or a covalent?
It would be ionic.
It's ionic. Yeah. There is a one misconception actually between students has that usually we study in O levels that the ionic bond is between metal and non-metal, right?
Yes.
All that is correct. But mostly ionic bond is between metal and non-metal. Okay.
Yes, sir.
in ammonium chloride, did you find any metal?
No.
No, there is no metal, but it has a ion. See, all ammonium compounds, not ammonium chloride only, all ammonium compound has ammonium ion in it. So they are ionic. Why? Because they have different ions in it. They doesn't have any atoms.
Yes, sir.
Okay. So next thing is type of proper structure and bonding can be predicted by physical properties like melting point, boiling point, electrical conductivity, and solubility. For example, if we don't know this, that whether it is ionic and or covalent, right? But if we study its property, we find that its melting and boiling point are very high. We see it is
It will be
solid in water. It does not conduct electricity in solid, but when it dissolved in water in aqueous, it conducts electricity. So all these properties will help me to conclude that it's ionic, because ionic compounds have a high melting and boiling point. They are mostly soluble in water. They do not conduct electricity as in solid, but when they become either molten or aqueous, they do conduct electricity. So these are the characteristic properties of ionic compounds. Is
Okay,
this
sir.
clear?
Yes, sir.
Okay, so here we have a few properties of ionic compound. Just read them and tell me if you have any issue regarding this, then we will proceed further.
Yes, sir.
Okay,
Could you scroll down?
yeah, sure. So first thing that is very important, that their structure is giant ionic structure, and that's why we don't say that they has a molecules. Okay, and in their giant ionic lattice, what we have oppositely charged ions arranged uniformly or oppositely charged ions at alternate positions. Okay, we have
Yes, sir.
these properties.
We have the giant lattice structure.
Yeah. So because of the very strong electrostatic attraction throughout the giant lattice, their melting and boiling point is very high, and the need, very large amount of energy to break these number of numerous bonds.
Yes, sir.
Okay. So most of them are water soluble. They are electrolytes. What electrolyte means that they conduct electricity in molten or aqueous, because ions, when they become molten or aqueous, the ions are mobile, the ions are free to move. In solid, they do not conduct electricity because ions are fixed at their position. They are not able to move, right?
Yes, sir.
Okay. Now, after this, we have a metallic bond. Metallic bonding, we know that there are electrostatic forces of attraction between positive metal ions and delocalized free moving electrons, right? So this is a metallic bonding. In metals,
Yes, sir.
the metal has a tendency uh, to, lose the electron. So what metals do, their atoms loses their electron. So those electrons are present in the empty spaces between the atoms in the lattice. These are the electrons. So what these electrons do, these electrons are moved like this. When they move, so this is the negatively charged. Uh, electrons are negatively charged, so they are attracted by the positively charged cations. So this attraction makes the metallic bond. Is this understandable?
Yes, sir.
Okay.
Could you
Now,
give an example? For metallic bonding?
Any example? Like, actually, it is very general. You know that like we have a specific examples of sodium chloride, magnesium oxide, calcium fluoride, and few more in ionic ones. Here we don't have any that specific example because, okay, there are two differences and one common thing between the metallic and ionic one. That ionic bonds, ionic compounds, ionic substances have a giant lattice, right?
Yes.
Metallic substances also have a giant lattice. But the difference is that in that lattice, in the ionic lattice, there are positive and negative charge ions. Okay.
Yes.
In metallic lattice, we have only cations and free moving electrons surrounding those cations.
Okay.
Is this understandable?
Yes, sir.
Okay, so we can further specify it like this. For example, if we see calcium, calcium is in group 2. So how many electrons calcium lose?
2.
Okay, actually today my internet is, I think, is little lagging. It's okay. So what we can do to specify it, instead of just making the positive these, we will put 2 positive in each cation. Like this. And instead of 1 electron, I
Okay.
will shoot 2 electrons lost by each atom. Did you understand?
Yes, sir.
If you have any query, please ask.
No. These electrons are of the same element.
Yes, from the atoms of the same element. And if it's a alloy, so there
Okay.
will be the same thing, that there in alloy we have a more than one type of metals mixed together, and all of them have lost their electron. So the electrons are moving in the spaces between the positively charged ion, and due to the movement of electrons, instead of repelling each other, those cations start attracting these free moving electrons, and as a result, they stay together and a metallic bond is observed. Is this clear?
Yes, sir.
Okay. Now, see, here I have made one summary. There is electrostatic forces of attraction. If I say in general that the electrostatic force of attraction exists between atoms or ions or molecules, then I can call it chemical bond, right?
Yes, sir.
If I say the electrostatic forces of attraction are actually held between the ions, then we call it ionic bond.
Yes.
And if these electrostatic forces of attraction exist between cations and mobile electrons, then it is a metallic bond.
Yes.
If these electrostatic forces of attraction are between molecules, then we call it
Intermolecular forces.
intermolecular forces. But before this would happen, that the electrostatic forces of attraction exist between the nuclei of 2 atoms and the shared pair of electron. When the 2 atoms share their electrons, they make a pair of electron. That pair of electron is attracted by the nucleus of those 2 atoms who shared their electron. So in this way, a covalent bond and a dative bond can be observed. For dative bond, there is a specific conditions that we will go discuss later when we are going to discuss dative bond in detail. Okay.
Okay.
So when the electron pair is shared between the 2 atoms, that pair of electron is attracted by the nucleus of those 2 atoms due to the electrostatic force of attraction, that is either covalent bond and dative bond. And due to this, a molecule is formed. And when the molecule is formed, the electrostatic forces of attraction also exist between those molecules, and that electrostatic force of attraction between those molecules is called intermolecular force.
Okay.
If you have any query, any question regarding this, please ask.
No, sir.
Okay. Now,
Covalent bond could be for more than 2 atoms, right?
no, for 2 atoms as well, or more than 2 atoms as well. 2 or more than 2 atoms.
Okay. Okay.
Okay. One minute, please.
Yes, sir.
Okay. So have a look at this. When we talk about a hydrogen atom, how many electrons hydrogen atom has? Only one, right?
Yes.
Okay. Now, so hydrogen atom, that valence electron, that is one is present in its first shell, isn't it?
Yes.
So it means that hydrogen atom needs one electron more, right?
Yes.
So, but if two hydrogen atoms come close to each other, think that can anyone able to lose its electron to give the electron to other atom?
No, because they both will gain one.
Yeah, because both need one electron, right?
Yes.
So if one electron loses the if one atom loses the electron, other will gain. So other will one have a duplet, but the first hydrogen atom has no electron in it, right?
Yes, sir.
So that's not possible. So what they do, instead of
Mm.
transferring, losing and gaining, they share the electron with each other. And sharing means that now after sharing the electrons belongs to both the atoms. So see how we will show the sharing. We show it by dot and cross. This dot, for example, belongs to, this is the electron belongs to this hydrogen, and this is the electron belongs to this hydrogen. Let me do this. See. But when they come closer and the electrons we make between the two atoms, then it means now these two electrons belongs to this one and this one both. So it means now this hydrogen has 2 electrons and this hydrogen also has 2 electrons. And as there is a one pair of electrons shared, so we will use only a single line to show this covalent bond, and we call it single covalent bond. Is this clear?
Yes, sir.
Now, what happens with the oxygen? If you see oxygen in the periodic table, you will find it in group 16, which means that it has a 6 electrons in its valence shell, right?
Yes.
So oxygen atom needs 2 more electrons.
Yes.
So when 2 oxygen comes to closer to each other, so both are the one who needs 2 electron, right? So instead of
Yeah.
losing or gaining, they are all going to share their 2 electrons with each other. As a result, see, these 2 electrons are shared. Up 2 pairs are now between the 2 atoms, right? So it means now
Yes.
these 4 electrons belong to this. Now, if you count this oxygen atom, it has a 8 electrons, right? And if you count the
Yes, sir.
electrons of this oxygen atom, it also has a 8 electrons. So as 2 pairs are
Yes,
shared,
sir.
we use 2 lines to show it, and that is a double covalent bond. Is this clear?
Yes, sir.
Okay. Now we have a nitrogen. Nitrogen is in group 15 and it has a 5 electrons in its valence shell. So each nitrogen atom needs 3 more electrons to complete its octet. So when 2 nitrogen atom comes closer to each other, both the nitrogen, each nitrogen atom share 3 electrons, and as a result, their octet is complete. Now see, if you look at this nitrogen, it has a 8 electrons. And if you see this nitrogen, it also has a 8
Yes.
electrons. And as 3 pairs are shared, so we use 3 dash line to represent this bond, and we call it triple covalent bond. Is this clear?
Yes, sir.
Any confusion or query so far?
No, no.
Okay. Now this is the small task for you. Can you try to make the dot and cross for these compounds?
Okay.
Okay, do it and then WhatsApp me. Okay. Chlorine, HCl, carbon dioxide, ammonia, methane. Yeah, they are fine. Very good. Okay. So for ammonia, it would be ammonia has 5 electrons, right?
Yes.
So 3 will be shared, each one with 1 hydrogen. And with methane, carbon has 4 electrons in the valence shell, so carbon share, it's all 4 valence electron, 1 electron with 1 hydrogen. And over here, it's C2H6, so 2 carbon atoms. They share 1 electron with each other, and rest of the 3 electrons with the hydrogen. So see, in each case, the octet of all the atoms is completed except hydrogen. Then it's ethene C2H4, so they are going to share 2 electrons from each carbon atom to the other carbon atom, and the rest of the 2 electrons with the hydrogen atoms. And then we have H2O, where oxygen has 6 electrons, so it will share 2 electrons, one with 1 hydrogen. So you did it well, very good. Okay, now. So what is a covalent bond? Okay, my screen was stuck. I was drawing, sorry. Let me share
Oh, I
it.
couldn't see.
Okay. So covalent bond. So covalent bond, as we discussed earlier, it is a force of electrostatic force of attraction between the nuclei of 2 atoms and a shared pair of electrons. So see, for example, if you recall the example of water.
Mm.
So this is the pair of electron, and it is shared by this nucleus and this nucleus. So that is a covalent bond. Is this understandable?
Yes, sir.
Okay.
But are you drawing something? Because I can't
Yeah,
see it.
I have drawn. Let me draw it again. I don't know today. My internet speed is very slow. Let me do it again. No, it's not showing.
No.
Okay, give me a minute. I'm sharing it again. Okay, so I'm see like this. For example, I was telling you this example. So see this, this is a pair of electron which is shared between these two. So this pair of electron is attracted by the nucleus of this hydrogen and this oxygen both. So that's what it says, that the electrostatic force of attraction between the nuclei of two atoms and a shared pair of electron. Is this understandable?
Yes, sir.
Okay. So the two atoms which share the electrons, they get stable. Why? Because they have either 8 electrons in their valence shell and or 2 electrons
Or
like for hydrogen. And rest of the atoms normally have octet in their outermost shell. So in covalent bonding, 1 electron is shared by each atom to form a shared pair. We call it bond pair as well. And the electrons which are present in that shared pair belongs to both the atoms between those atom that pair is present. Is this understandable?
yes, sir.
Okay, so sometimes after the covalent bonding, the valence shell does not contain 8 electrons in it. The compounds in which such atoms is present are called electron deficient compounds. So basically, it means the valence shell does not, or I think I must write it like this, that the valence shell has less than 8 electrons in it. Okay, you are observing the 3 examples below. Can you make the dot and cross for these 3 quickly?
Sir, I've sent you the picture. Sir? Sir?
Oh, sorry. Yeah, I was telling, I was saying that you missed the valence electron, the rest of the valence electrons of chlorine, otherwise your diagrams are perfect.
I missed which
In
one?
BF3, fluorine, the 6 electrons of fluorine, and in AlCl3 and BeCl2, the 6 electrons of chlorine are left. See?
Oh, yes, the remaining ones.
Yeah.
Sorry, I didn't draw them.
Otherwise, there is no mistake. Okay.
Okay.
So now if you see, fluorine has octet complete, but boron doesn't. Boron has
Yes.
6 electrons in it. Same case with the aluminium chloride, chlorine, 6 electrons are, chlorine has an octet now, but aluminium doesn't has octet, it has a 6 electron in its valence shell after the bonding, right?
Yes, sir.
And in barium chloride, chlorine's octet is complete, but beryllium has only 4 electrons in its valence shell. So these kind of cases are considered as, electron deficient compounds.
Okay.
So see, now if you see, do you have a periodic table with you?
Yes, sir.
Okay, can you find the position of a beryllium in periodic table where it is?
Group 2,
Group 2, so
period 2.
it means it's a metal, right?
Yes.
And chlorine is in which group?
Group 17,
So it means it's a
non-metal.
non-metal. So if one is a metal and the other one is a non-metal, so it means that it isn't it, it can form a ionic one.
But these
See,
two aren't ion.
yeah, this is not ionic, but see, I'm connecting it with that point that most of the time students remember ionic bonding is the one which has a metal and a non-metal. So see here you are observing a metal and a non-metal both, but it is a covalent.
Yes.
So you can't remember it like this. You always remember it by the electrostatic forces of attraction. Electrostatic forces of attraction between the oppositely charged ions, it's ionic bonding. Electrostatic forces of attraction between the nuclei of the two atoms and the shared pair of electron, it's covalent bonding. Electrostatic forces of attraction between the cations and free moving sea of free moving electrons, then it's a metallic bonding.
Okay.
Okay, and now with the aluminum chloride, you must remember this thing that it is covalent at higher temperature only. Okay, so due to the change in temperature, it becomes ionic and or covalent. Okay,
Okay. And sir, in ionic bonding, there would be no electron deficient compounds, right? Because they both would have oppositely charged.
yeah. Normally, what happens that in ionic bonding, usually one loses the valence electron, so its inner shell becomes the outermost, and it has already filled, completely
Hmm.
filled. And the one which gained the electron has electrons, but it has 1 or 2 or 3 electrons less than the octet, so it gained those 2, 3 or 4 electrons, and as a result its octet is completed. So that's why we don't have any electron deficient compound over there.
Okay.
Till here, is this clear?
Yes, sir.
Okay, now if I ask you to draw the dot and cross diagram for these uh the new 3 examples.
Okay. Sir, I've made the diagrams, but they're
Yeah.
kind of small, so the numbers may not be that visible.
Mm, okay.
Can I make them again?
No, 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 that's fine. Just have a look. You made PCl5 correct. You made SF6 correct. But count the atoms in oxygen. How many electrons of oxygen has in its valence shell?
6.
So if you see your diagram of SO2, isn't it you showed that 7 electrons
Uh,
of oxygen in its
yes,
valence shell?
yes.
You see, that's the mistake. Now, can you try to
Mm,
correct it, or I will show the correct diagram?
I'll try to correct it.
Okay, correct it. Then after that, I will show you. Mhm.
Yes, sir.
Okay, that's fine. Now, if you count the electron for phosphorus, sulfur, and sulfur in all these three, you will find that phosphorus has 10 electrons in its valence shell instead of 8. In sulfur dioxide, sulfur has 10 electrons in its valence shell. And in SF6, sulfur has 12 electrons in its valence shell, right?
Yes, sir.
So these cases are called that they have their expanded octet, in which the one of the atom has more than 8 electrons in its valence shell. Till here, is this clear?
Yes, sir.
Okay. Now, how they are able to accommodate more than 8 electrons in this their valence shell? That's what we will be going to discuss in our next class.
On Monday, right?
Yeah, inshallah, on Monday.
Inshallah. Okay.
And I will share this file with you. You can go through. And one more thing, I will share the paper one MCQs questions of atomic structure and the modes with you as well.
Okay, sir.
Okay. Okay. So see you inshallah on Monday.
Inshallah.
Inshallah. Okay. Take care. Goodbye. Allah Hafiz.
Allah Hafiz.